Hello, my name is Beth Dixon, and this is a review for Math 1830, and this is for section 0.5. So this is 0.5, and this is to evaluate algebraic expressions for given variable values, including how to enter the problems in the calculator and to perform operations with algebraic expressions. And we'll spend quite a bit of time on how to do some neat things with the calculator that you may not have seen before. So let's just begin. The TI-8384 calculator is the calculator that is required. I have a TI Smart View calculator that lets the computer run the calculator for us. Let me change. I don't want to do the, I want to, there we go. That allows the calculator to be run on the computer. So it won't look exactly like the TI-83 or 84, but it looks fairly close. So we'll go with that. As we do that, it should also give us a key history so that you can pause and make sure you understood which keys I used. First of all, we're going to look on how the TI-83 or 84 calculator can use the store button. So let's say that I did a complicated problem like 7.2 squared plus 3 times 7.2 minus 7.2 divided by 6. So let's say I put that in the calculator. I will hit parentheses 7.2 the calculator does not like the way I type 0.2 in the parentheses. Then I'm going to raise it to the second power. When I do the raise button on a TI-84 or later calculator, I have to use the over button to get out of the exponent. So I did that. Plus 3 parentheses 7.2, close the parentheses, minus 7.2 divide by 6 and enter. And that gives me a decimal answer. I was hoping for a little uglier answer, but it gives me 72.24. Now let's say that I'm going to be using this answer a little bit later. So I want to be able to store this answer. So I'm going to press the store key on the calculator. It will take my previous answer and store it somewhere. And I want to store that in one of the letters in my calculator. Notice on your calculator that the letters are green. And so the alpha key is green. So to get one of the alpha keys, what I will do is, since it's green here, I will use the green key to then get either the A, the B, the C, the D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, or Z. And that will get those keys, which are part of the alphabet. So I'm going to erase all that because that's in our way. So let me erase that. And then let's press the keys that I will need, which in this case, I'm going to store this in A. So that answer will be stored in A. So we'll go over enter. Now let's say I've done some problems, and what I want to do next is I want to then take and do some algebra. And let's say after doing some algebra, I come up with an equation that is x to the third plus 3/2 x squared minus 1/3 x. And because of that, I now want to take the answer I got in my previous problem and plug it into this equation. To do so, I can simply do it one of two ways. I can, and the easiest way is, since I put it as a, I can type in a to the third plus 3/2 a squared minus 1/3 times a. And to do so on the calculator, what I will do is do alpha a raised to the third, arrow over to get it out of the exponent, plus, it's a parentheses for my fraction. So that would be 3 divided by 2 in the parentheses for my fraction. Then I'm going to put my alpha a, and it's raised to the second. So I'll raise it to the second and arrow over, minus, and then the next fraction, which is 1/3, 1 divided by 3. And then the a as well. Notice this time I'm not going to put it in parentheses. We can put it in parentheses, but we don't have to. I emphasized by putting it in parentheses when I wrote it, but the calculator doesn't need to. And it will substitute that in and give us an answer of 384,796.7818. And that's probably the easiest way to do this problem. There's some other ways that I could show you, but we'll just use that. And that's a nice way to use store. We can store an answer into A. Let's look at the next slide, and that's how to use the ask on the table feature. Let's say that we have an equation such as y equals x to the third plus 3x squared minus 2 divided by x. And for whatever reason, I needed to plug in some table values. Let's say I needed to know what -2 is in this equation. Let's say I needed to know what -1 was. And let's say I needed to know what -1/2 was, what 0 was, what 1.3 was, 4.3 and 5 was. Let's say I needed those values to figure out what those values, or the y values for those particular values for my equation, y equals x to the third plus 3x squared minus 2 over x. I could plug those in separately and type every one of those out here on the home screen, and I could substitute each of those in, but that would be a lot of work. So I'm going to start by using my y equals. I'm going to clear out my previous equation. I'm going to clear out all these other steps that were from the previous problem, so you can look at the key press history fresh for this problem. And I'm going to type in x raised to the third power plus 3x. Now notice what I did here, and I do this quite often. I used 3 raised to the third power, but I forgot to arrow down. And that's why I say arrowing down is important. So I'm going to have to back up and delete, and then I'm going to have to remember to arrow over to get out of my exponent. That's how important that is. Then I'm going to hit my plus 3. X, and then I'm going to use the X squared button this time because it's the shortcut and I don't have to remember to arrow over if I'm using the X squared button. It is already back down out of the exponent mode. Minus 2 divided by X, and I'm going to press enter. I'm going to go second table, and in this case, the last time I used this table, it was set to ask. Normally it is set to auto, so if I hit enter and then auto, on the word independent, normally what you see in a table is this. You see a table. In this case, it started at -4 and it put in values. And I could find -2 and know that if I plugged in -2 into this equation, I would get 5. And so that would be the answer for the y value if I plugged in -2. If I plug in 0, I get an error, which means 0 is not in the domain. So how can I plug in the other values? Well, some of them, again, the -1 would be easy, the 5 would be easy, but some of the rest of these would be really difficult to plug in. So we can use what is called the ask feature. To get there, we want to press second and then table set. And in the table set, we have independent and dependent. The independent is the X, the dependent is the Y. So if I come down here and arrow down to where it is on auto for independent and change that auto and arrow over to ask and press enter, it toggles on and off. It toggles the auto off and the ask on. If I want to toggle back the other way, I come back over to auto and press enter, and it toggles the auto on. So whichever one I want on, I hit enter when the cursor is over top of it. So now it's on ask. If I go back to second table, it clears out the table and I can type in values. If I type in a -2, it gives me that 5 that was in the table. It plugs -2 in. The next value I want is -1. So I'll type in a -1 and then enter. That gives me 4. Now let's type in -1/2. I don't even have to figure that out as a decimal. I can just type that in as -1/2 and press enter. That gives me 4.625, and that should work out fine. Next, I can look at 1.3. No, well, next let's look at 0. I forgot that. Let's arrow back, clear that out. Type in 0 because I already had an answer for 0. I skipped. And if I press 0 and enter, I still get that error that I found out earlier. The reason is because 2 divided by 0 is not allowed, and therefore 0 is not in the domain. The next value in my list is 1.3, and if I type in 1.3, which also would not show up in a normal table, but it shows up quite nicely here, gives me 5.728.5. Now notice that if I arrow up and over, that actually is not 5.7285, but 5.728538461154. The division causes it to be a non-repeating, ending decimal there, but it rounded it to 4 places, which is all the view would allow it in the table. And since I will round to 4 decimal places, that's good enough for what we're doing. The 4.625, because of the arithmetic, is actually 4.625, and it does not require any rounding. So sometimes you may want to check over in the other column to see if it rounded the number or whether that is the complete decimal. So now let's try 4.3. and that gives me 134.51. But because that's only 2 decimal places, I'm going to come up and over and see that that's 3.4511, and then that 8 needs to be rounded up to a 9. And I'll keep that to 4 decimal places. And so then I can come over, and the next number, or the last number in my list, is a 5, and enter, and that gives me 199.6, and that number is rounded. It's the complete number. There's no need to round it. It is 0.6 and doesn't have any additional decimal places. So we can see that this ask feature is really helpful when we're putting multiple numbers into an equation. We can actually even use it if we're just putting a single number in, but it might be just as easy to put that out on the home screen. Okay, let's look at the next slide, which is to evaluate for the given values, give exact answer, and also rounded to 2 decimals. So let's go back to y equals. Let's clear out my steps. Let's clear out the y equals, and let's type in the equation that we have here, which would be 3x raised to the second, and because that's an exponent, I need to arrow over, minus 5x plus 2 divided by, and because there are 2 parts to this right here, to the 3x to the third, 3x squared minus 5x plus 2 over 3x to the third. The 3x to the third is all under the division sign. So to make sure that it is all under the division sign, then we will want to put all of it in parentheses. So I'll open a parentheses and then type 3x raised to the third, come out of the exponent, close the parentheses, and press enter. And that will be my equation. Then we're going to press, and we want to know what -2 is. Well, we can go to second table, and we're still in that ask mode. And what I'm going to do is delete each of these items that were from the previous example. So I've cleared out my table. Then I want to type in the value that I have here, which would be -2. Once I've done -2, I will press enter. It will plug that in. I will go up and over to look at the entire number, and that gives me 21.91 repeating sixes. Notice the 7 here has been rounded so that that's what shows, but it is actually repeating sixes. Now it says to round to 2 decimal places, so that would be 21.92. It also asks for an exact answer. I cannot get the exact answer easily from 21.916 or repeating sixes. So the best way to get an answer here would be to use the home screen. To get to the home screen, press second and quit, and that brings you back out to the home screen. We can do this one of 2 ways. First, we could just type in 3 parentheses. Whoops, don't ask me why I hit the mode key. I was supposed to hit the X key. Well, let's just hit X. Except it didn't do what I wanted it to. So let's press clear, clear, clear. Okay, there we go. Let's try that again. 3x raised to the second out of exponent. Well, it didn't hit to the second. raised to the second over minus, what am I doing? I'm going to press clear again. Clear. There we go. Let's try this again. Didn't mean to hit X. I meant to hit the value that our X is, which is -2. So 3 parentheses, -2 end parentheses, raised to the second power down from the exponent -5 parentheses, -2 end parentheses plus 2 divide, then start a parentheses. Again, because there's more than one thing, we need parentheses around the denominator. And don't forget your division sign. I don't know what it is, but myself and students both tend to forget that division sign because we get into such a hurry at trying to remember the parentheses. Then we're going to press 3. And then I'm going to put parentheses again because I like to put what I'm plugging in parentheses. So that would be the -2. And then close the parentheses for the -2. It's going to be raised to the third power. Arrow over to get out of your exponent. And then close the parentheses on the bottom. And then press enter. Okay, and that gives me the same answer, which it should. It shouldn't give me something different. But at this point, in other words, what I did is just went 3 negative times -2 squared minus 5 times -2 plus 2 divided by 3 times -2 to the third, and then pressed enter and got the 21.9191. I can't write. And got as an answer 21.91 repeating sixes. The problem is I want an exact answer, so I need to get this as a fraction. So I will press the math key and enter for fraction. It will change that previous answer to a fraction and give this to me in fraction form, which is 263 divided by 12. And so then there's my decimal form at 21.92 and my fraction form at 263 divided by 12. An easier way to do this would be to use the fact that I have stored this in Y1. So I would hit second and quit and get out of the screen, and I would pull up the Y variable. Remember, I said I put it in Y1. And so what do I want to do? I want to plug in -2 into Y1. If I press the vars key, arrow over to Y vars, and whoops, not color, Y vars, and press enter, I get a list of my Y variables, which is Y1. And these are under function. And so we press enter, and that gives me Y1. And then in parentheses, I'm going to put a -2 because that's what I'm going to plug in. Notice that this looks like your function notation. Y of -2 or Y1 of -2 to be specific. So this is how we do it. And if I press enter, that will do the exact same thing and give us the 21.9166. And then press math, fraction, and enter, and that will give me the fraction form as well, which is the 263 divided by 12. Either way is good, so we can do, and I don't like that Y1, so we're going to go Y1 of -2, and we can get the same answers that we did previously, and that is a nice way to evaluate a function. As we look at the next problem, we can give an exact answer and also round it to 2 decimal places. Notice it's the same equation, but we've put in a different value for x. Now we want to do it for 0.2. So let's do it the way we just finished, which is using the y1. So we're going to go vars, we're going to choose y variables, and we're going to choose function, and we can either press enter or select 1. That brings up the y1 and the y1. I don't like the way that y1 looked. My handwriting is atrocious on that, y1. And then we're going to type in 0.2 and then enter. So I'm going to select the y1. I'm going to type in a parentheses, 0.2 in the parentheses, and that will just plug it in. Remember, we can do that because we stored in y1 the equation 3x squared minus 5x plus 2 over 3x to the third. This gives us 82.45 and then repeating threes. To round to 2 decimal places, that gives us 82.45, and then using the math key and then choosing 1 for fraction and enter to tell us to do it, that gives us as a fraction as 61/84 over 75. Now, technically that should be equals, and this over here should be approximately 82.45. It's exactly 61/84 over 75, but approximately 82.45 when we round. Now, we could do it with the y equals, since we have it in y equals, and then use the table. And then in the table, we could type in the 0.2 and enter, and that gives me the decimal format. So if all you needed was the decimal format, the ask menu is very helpful. Now let's look at the next example, which now instead of using the calculator, we will use our algebra. The calculator is great for numbers, but it does not do our algebraic manipulation. So this is problems that we're going to do here. Notice we have 3x squared plus 5x minus 4 in parentheses plus 2x plus 1 in parentheses. There is an addition sign between the two parentheses that tells me I'm going to add. When I add, no signs change. We're adding like terms, and we're not going to change any of the variable parts. I'm just going to find like terms. So for me, what I would do is I generally copy down the first parentheses plus the second parentheses and drop the parentheses. So I have 3x squared plus 5x minus 4 plus 2x plus 1. Now I'm going to look at my like terms, and I have only one 3x squared, no other x squareds. So I will bring down my 3x squared. Then I'm going to look, and I have a 5x and a 2x, which would give me plus 7x. And lastly, I have a minus 4 and a plus 1, which gives me a minus 3. So my answer then would be 3x squared plus 7x minus 3. Now went the wrong direction. I'm going backwards. Our next problem is in parentheses 3x squared minus 5x plus 3 minus in parentheses 2x squared minus 4x plus 3. So I'm subtracting in this case because there is a subtract sign between the two parentheses. When I subtract, remember that it changes the sign of everything that follows the subtract sign. That means that I bring down the 3x squared minus 5x plus 3, and the minus sign will distribute to the 3 parts of the second parentheses. So the positive 2x squared becomes a minus 2x squared. The minus 4x becomes a positive 4x, and the plus 3 becomes a minus 3. You can think of that as multiplying a negative 1 through. A negative 1 times a positive 2 gives me a negative 2, a negative 1 times a negative 4 gives me a positive 4, and a negative 1 times a positive 3 gives me the negative 3. Now, I did not say the x's, but they are included. So now we have 3x squared minus 5x plus 3 minus 2x squared plus 4x minus 3. So we want to look for like terms, and I have 3x squared and a negative 2x squared. So 3x squared minus 2x squared would be 1x squared, or just x squared. Then we have negative 5x and a positive 4x, which would give me negative 1x, or just a negative x. And then we have a positive 3 and a negative 3, which would add to 0. And so then our answer would be x squared minus x, and we do not need to write the plus 0. So that would be our answer, x squared minus x. Let's look at the next set of problem, or the next problem. And in this one, we have 5x squared in front of parentheses, inside it being 4x minus 3x squared. That indicates a multiplication. We have a term in front of the parentheses without a plus or minus or times or divide, so that indicates a multiplication. So we will multiply the 5x squared times both the 4x and the 3x squared. So what will that give me? Well, for the first one, I get 5x squared times 4x. I multiply sign, number, and then variable. A positive times a positive would be a positive. 4 times 5 would be 20. X squared times x would be x to the third. Notice in multiplication that we do change our variable parts, but in addition and subtraction we do not. We change our variable parts here because an exponent tells me how many are multiplied. I have 2 multiplied here times the understood 1 multiplied in the second one, so I'm multiplying of 3 x's. So that would be 5x squared times 4x, which would be 20x to the third. Then I would have 5x squared times the negative 3x squared, which would be a positive times a negative is a negative. 5 3s are 15. X squared times x squared would be x to the fourth. So my final answer would be 20x to the third minus 15x to the fourth. Let's look at our next problem, which would be 3x minus 2 in parentheses times parentheses 4x plus 1. How did I know it was times? Because there is no symbol between the two parentheses. It's an understood multiplication problem. So now I'm going to bring this up here, and we use a double distributive or FOIL method to multiply. And as we do that, we're going to multiply the first 3x times 4x, that is the first, and 3x times 4x would give me 12x squared. Next, we're going to multiply the outside of these parentheses, which would be 3x times 1, which would be plus 3x, and that's your outside. Next, we're going to look at the inside, which are the two inside terms, which would be negative 8x. And then lastly, we'll look at the last of the two parentheses, which would be negative 2. That then allows us to combine to get our answer, which would be 12x squared plus 3x minus 8x would be minus 5x minus 2. Now, also notice, and I tend to do this more than I think about FOIL, is I take my first term of 3x squared. Now watch me move that. I take my first term of 3x squared, and it gets multiplied for the first and then the last, and the negative 2 gets multiplied by the first and then the last. And that's how I end up with that. Now, I forgot to write that that was the inner, but that is your FOIL, and that's how you multiply two parentheses together, two binomials. Okay, let's look at the next problem, which is in parentheses 2x minus 3 squared. So when I do this, the first thing I want to do is to rewrite that by definition. So this would be 2x minus 3 times 2x minus 3. Squared means to multiply a number by itself. So that's the first thing I would do. Then I'm going to use the FOIL method or the distributive method to multiply this. So the first thing I'm going to do is take that 2x, 2x and multiply it by the 2x and multiply it by the 2x and get 4x squared. Then I'm going to take that 2x and multiply it by the negative 3 and get, well, that's going to stay up there. We'll erase that and get negative 6x. Then we're going to take, and that multiplied the 2x by both terms. Then I'm going to take the negative 3 and multiply it by the 2x and get another negative 6x. And then I'm going to take the negative 3 and multiply by the negative 3 and get a positive 9. That then leaves me with an answer of 4x squared minus 12x plus 9. And so that should then be the answer for this problem. Now, we want to write the next one as a single fraction and as two terms. So as we do this one, this is the division problem. We've looked on how to add, we've looked on how to subtract, we've looked on how to multiply. Now we need to look on how to divide. This is 3x to the third minus 12x over 6x. And so as we look at this one, when we divide, the first step is to factor. If you've not watched the factor video, you may want to do that video first. This would then factor 3x to the third minus 12x, which we will look for the greatest common factor. 3 goes into both 3 and 12, and they both contain a single x. This one contains 3, this one contains 1, so the common factor would be x to the first. So as I look at 3x to the third minus 12x, I can factor out a 3x. If I factor out a 3x, it's like dividing 3x into 3x to the third. If I do that, that leaves me x squared. How do I know that? Because 3x times x to the third would give me back 3x to the third. 3x times x squared would give me back 3x to the third. I'm not sure I said that right the first time. I did say it right the second time. Then 3x times what would give me back 12x? Well, times 4. 3x times a negative 4 would give me back a negative 12x. So this right here is the factored form. Now, it is not completely factored, but for our purposes, it's factored enough. So I'm going to come back over here and I am going to write it in factored form. This will give me 3x times x squared minus 4 over 6x. Now, as I look at that, I want to write it as a single fraction. So I'm going to leave this as a single fraction and reduce. 3 goes into itself one time, 3 goes into 6 two times. X goes into itself one time, X goes into itself one time, and I'm left with x squared minus 4 over 2. And that is a single fraction and it has been reduced. Now, we've not looked at the factoring video yet. It is the next section. This is 0.5. Factoring is 0.6. So I will not talk that x squared minus 4 can actually be factored again. What I will do is I will come back over here and talk about how we can write it as two terms. If I'm going to write it as two terms, I can think about a fraction like this. If I have 1/2 plus x over 2. Both of these have 2 as a denominator. So I can share that and they share a common denominator. So I can write that and write 1 plus x, and that would all be over 2. That is combining and adding those. Since I can't simplify the x plus 2, that doesn't change anything. And I mean, since I can't simplify the 1 plus x, it doesn't simplify any further, and that is the answer. But that would be the answer altogether. Now, what that does is this then gives me a problem, and I can go in this problem, I can go from this form, I can go from this form to this form, or from this form to this form. Generally, we take fractions and add them together, but I can go backwards. I can take a problem that looks like this and go backwards to this. So let me take the part out that I don't want, which is all this right here. I'm going to erase all that, and I'm going to make this, well, I'll make that a little bit smaller so it's out of our way. And what I'm going to do is I'm going to take my pen here and I'm going to write this one as two fractions. I can write it as 3x over 3 over 6x minus 12x over 6x. Basically, if they have a common denominator, I can add them together, or in this case, subtract, and write it over one denominator. Well, if it's over one denominator, I can do the reverse, which is write each of the numerators over that one denominator and show it as a split fraction, which is what I've done here. Then I can reduce this first part, which would be 3 goes into itself one time, 3 goes into its 6 two times. X divides into x to the third and leaves me x squared. So that would be x squared over 2 minus 6 goes into itself one time, 6 goes into 12 two times. X and x divides into itself one time. So that would then be minus 2. So this would be the single, that would be as two terms, and this would be the single fraction. So this would be an answer as well as this being an answer. So we have x squared minus 4 over 2 and x squared over 2 minus 2. We could have also taken x squared over 2 minus 4 over 2 and reduced it down to this form to get that two-term answer. Next, we have 2/3 times 4x squared minus 3x plus 1/2. As we multiply this is multiplying a coefficient through each of these. So this is going to take 2/3 times 4x squared minus 2/3 times 3x plus 2/3 times 1/2. Now I can do this relatively quickly and get 8/3 x squared minus 2x plus 1/3. How did I get those answers? Well, I took the 2/3 and I said, I took 2/3 times 4 over 1 and got 8 over 3. I took 2/3 times 3 over 1, divided out the 3's and got 2. I got 2/3 times 1/2, canceled out the 2's and was left with 1/3. That's exactly how I did it. But if you're not as comfortable with your fractions, you may want to pull out your calculator. And I'm going to second quit to get back to the home screen. And I'm going to pull mine over here because these are the problems we're doing. And I'm going to put 2 divided by 3 times 4, enter, which is 2.66. That's this one right here. Whoops, that's this one right here. And that gives me math fraction, enter, which gives me the 8/3. And then looking at parentheses, 2 divided by 3, enter, times 3, enter. Whoops, not times 33. That's not what I want to do. 2 divide 3, close, times 3, enter, which gives me 2. And the last one here, which would be parentheses, 2 divided by 3, close parentheses, times 1 divided by 2. And it should give me another fraction, which I can change to 1/3. And so that's how you can do it as well. You can do it any way that you choose, and it should work. The answer then is 8/3 x squared minus 2x plus 1/3. Next, we have 2x to the 1/2 plus 3x to the 3/2, and that should give you, well, we're going to multiply, and we would multiply the coefficients, which give you 6, and then we would have x, and since these are like bases, we would add the exponents, and so that would be 1/2 plus 3/2, and you can do that on the calculator. If I did, that would be 1 divide 2 plus 3 divide 2, and then enter. Either way, that should give you 2. I did it by hand by getting 4/2 and then simplifying. So that would then be 6x squared. So that rule for exponent holds true even if the exponents are fractions. The same thing here, but we have the square root of x times the square root of x over 2. So if I have the square root of x, remember that that is the same as x to the 1/2 power. So if that's the same as x to the 1/2 power, then what that does is it that means that we can rewrite the first one as x to the 1/2 times x to the 1/2 over 2. So I'm just going to leave that as over 1. So on the bottom, we get 1 times 2, which is 2. On the top, we get x, and we add these exponents. And 1/2 plus 1/2 equals 1. So that'd be x to the first. So that's going to be x over 2, or 1/2 x. Remembering there would be an understood here, and we can pull the 1/2 times x, which would be the same as the x over 2. Your practice from your textbook would be page 32, problems 7, 9, 11, 14, 15, 19, 23, 25, 29, 33, 37, 49, 51, 61, 63, and 65. If you need to get in touch with me, remember my name is Beth Dixon. You can reach me at Beth Dixon. Oh, that's horrible. Let's erase that last part. That Dixon and at, the N and the A just went right over top of each other. So Beth Dixon at ws.edu. And remember, I'm located on the Morristown campus in the Math and Behavioral Social Science Building, room 222. Thank you for watching.